Alright, so when he jumps off, right before he hits the water, that's going to be 3 meters. That's the initial height. And when he hits the water all the way to the final, that's 2.15 meters. That's the final height. So in part A, they want us to find the speed when he hits the surface of the water. So there's two terms we can cancel out or make zero, and that's going to be the final potential energy, because his final position is zero. The final position is going to end up being zero, and we don't know that. And also the non-conservative work, because there is no non-conservative work, because we're assuming when he's in the air, negligible air resistance. So the only force that's acting on him is gravity, and that's a conservative force. So this is what it simplifies to be. I expanded each term. So he weighs 76 kilograms. Initially, he's traveling at 5.94 meters per second. And his initial height is 3 meters. Okay, and this is going to be kinetic energy, initial kinetic energy. And his total initial kinetic energy is 3,574 joules. Now we would set that equal to this, okay, which is the final kinetic energy. Okay, that's the equation for that. And we want to know what Vf squared is. So we get that on one side, take the square root. So A happens to be 9.7 meters per second. Now in B, we want to know, below the surface of the water, what's the force with which it's pushing up against him. So, so that is gonna be two terms canceled out, and we can go ahead and cancel out the initial potential energy because he's on the surface. He's on the surface. They're talking about on the surface, and and they want to know below the surface, okay? Because we don't know where he stops, okay? Because we don't really know where he stops, so that's why initial potential energy is zero, and the final kinetic energy is also zero because he has stopped at that point. Because when he reaches the end here, he has stopped, and his kinetic energy at that point is zero. So those are two terms we can go ahead and cancel out. That's what it simplifies to be. The initial kinetic energy is the same as before. We don't know what the WNC is, and this is the final potential energy. And the final height is negative 2.15 meters. Okay, so once we do the math, it comes out to be negative 1,601 joules on this side, the right side. And we're going to bring this over the kinetic energy initial over to this side to get what WNC is. And WNC is a negative 5,175 joules. So, but that's work. They want to know what force is. Well, we have work. We have the displacement. Okay, and the cosine is just a straight line. Okay, the cosine is a straight line, and that's 180 degrees. So it's going to end up being, right here, this is going to end up being 2.15 multiplied by the cosine of 180, and that comes out to be a negative 2.15. So now we go ahead, move it over to the other side to get F by itself. We divide these two terms, and the force is 2,407 newtons.